Hello students, today we will be learning about arithmetic progression. That is the meaning of the term arithmetic progression. Now, first of all, generally speaking, when we talk of a sequence of actions, we imply that there are multiple actions which may be related or unrelated. That means for example, if we have a number of actions as getting up in the morning, fighting, going to bed and working. See, these actions are totally unrelated to each other. For example, when we get up in the morning, the first thing we do not usually do is start fighting. And we should not do it as well. So these two actions are not at all related to one another. See, this fighting and going to bed or working, these are totally unrelated actions. These actions are totally unrelated to each other. We do not have any relation between these four actions. But if we have the actions as getting up in the morning, getting ready for school, having breakfast and catching the school bus, we have a sequence of actions which are related to one another. They are done in sequence. They come one after the other. We get up in the morning, we get ready for school, we have our breakfast and we then catch the school bus and go to school. So these happen in succession. These are related to one another and they refer to the series of actions that we usually perform on weekdays because we have our schools on weekdays. So these four actions are related to one another. But over here, the first set of actions are totally unrelated to each other. Similarly, now talking about mathematics, we can have a series of numbers which may be related or unrelated. For example, if we have a series of numbers like 1, 10, 3, 5, 100 and -6, we see that there is no pattern present in the series. That is, the numbers are unrelated to each other. We have the first number as 1. We cannot say what will be the second number. We are seeing that the second number is 10. So the first number is 1, the second number is 10. We do not have any clue regarding the third number. What will be the third number? Because there is no pattern present. There is no law which will be governing which number will be coming next. Which numbers will be present in the series, because there is no law, so we can say that these numbers are totally unrelated to each other. But now if we have the series as 2, 4, 6, 8 and 10, then we see that every number in the series except the first one, that is 2, can be obtained from the previous one by adding a 2 to it. 2 doesn't have its previous number, so this is an exemption. But as soon as we get 2, that is the first one, we can get the succeeding terms from this 2, starting from this number 2, by adding a 2 to each number. If we add a 2 to this first term 2, we'll be getting 4. To this 4, if we add a 2 again, we'll be getting 6. Now 6 plus 2 gives us 8. 8 plus 2 is 10. So we see that every number present in this series is governed by some law. These numbers do follow a specific pattern. What is the law? That is, every number except the first one, can be obtained from the previous one by adding a 2 to it. That is the law. So this is the pattern that is being maintained and followed by each of the numbers which are present in the series. This series cannot have any terms like 3, 5, 7. This is an even number series. This is a series containing 5 even numbers. So we know that which numbers can be present in this series and which numbers cannot be present in this series. So because there's a definite law, there's a definite pattern in this series. So these numbers are related to one another. So the numbers of this series are related to each other. There exists a definite pattern between them. Now we call the first series as a sequence. That is this one, which do not have any pattern, where the numbers are totally unrelated to each other. This sort of a series is known as a sequence, whereas the second one is known as a progression because there is a definite pattern present in this series. So a series which has a definite pattern, a definite law which governs each number present in the series is known as a progression. Now let us take the following 3 series. The first one is 3, 6, 9, 12 and followed by 3 dots, implying that there will be more terms as well. There are more terms in this series. We have written just the first 4 terms. The second one is 25, 20, 15, 10, 5 and 0. This stops over here. And for the third series, it is 2, 4, 8, 16 and this will continue as well because there are 3 dots after 16. So we have 3 series. Now we find that the first and the third series, that is this one and this one, 3, 6, 9, 12 and followed by 3 dots, as well as this one, 2, 4, 8, 16 followed by 3 dots, do not have the end number. Like the second series, this is the last number that we are seeing. But over here we are not having any last number, but there are 3 dots. This implies that we do not have any last number for these 2 series. These 2 series will continue forever. It will never end. That is, the 2 series do not end anywhere. Such series are known as infinite series. That is the first one, that is this one, 3, 6, 9, 12 and so on, as well as the third series 2, 4, 8, 16 and so on. These 2 are known as infinite series. Any series which continues is given by say 3 or 4 or 5 terms, and those terms are followed by these 3 dots, indicating that they are infinite series. They do not have any end number. But the second series contains 6 numbers. You see, 25, 20, 15, 10, 5, 0. There are 6 numbers present in the second series. And these hence have the end number. The end number is a 0. End number or term. Every number present in any series is known as a term. So this is the end term. Such series which contain a fixed number of terms is known as a finite series. This do have an end term. This does not go on forever. So this is a finite series. For a finite series, we can say how many terms are present in a finite series. We can just count the number of terms. But for an infinite series, we cannot say the count of the numbers that's present in the series, because it just goes on. We do not have the nth term for an infinite series. Now let us take up the same three series, 3, 6, 9, 12 and so on. The second one is a finite series, 25, 20, 15, 10, 5, 0 and it ends. And this is again an infinite series, 2, 4, 8, 16 and so on. Now we see that in series 1, that is this one, every term following the first one, leaving this first term 3, every term can be obtained by adding a plus 3 to the previous term. See, if we add a 3 to this first term 3, we get a 6. 6 plus 3 gives us a 9. 9 plus 3 gives us a 12. So the next term, the fifth term will be 12 plus 3, 15. The sixth term will be 15 plus 3, 18 and so on it will go. So every term can be obtained from the previous term by adding a 3 to it. That is the law of this first series. For the second series, we find that the common number, see this is a common number. Throughout this first series, we are adding a plus 3 to each number to get the next number. For the second series, we find that the common number that has to be added to the preceding term to obtain the succeeding term is minus 5. 25 plus minus 5. 25 plus minus 5. This will be giving us 25 minus 5, which is equal to 20. Similarly, 20 plus minus 5 will be giving us 20 minus 5, which is 15. Again, 15 plus minus 5 will be giving us a 10, then 5 and 0. So, every time we are adding the same common number, that is minus 5, to the previous term to get the next term. Now coming to the third series. In case of the third series, we find that the successive numbers can be obtained from their previous ones by multiplying them with 2. You see, 2 when multiplied by 2 will be giving us a 4. 4 multiplied by 2 will give us an 8, and 8 times 2 is 16. 16 times 2 will be giving us a 32. So the 32 will be the fifth term of the series. We do not have any number that can be added, and which when added will be giving us the next term of this series. Since all the above three series follow some pattern, they are all examples of progressions. For the first two series, we are seeing that there is a common number which has to be added to a number to get its next number, following number. And for the third series, we are seeing there is a common number which has to be multiplied to each number to get the next number. So there is a law present in each of these three series. So they are all examples of progressions. Now taking up the first two series, 3, 6, 9, 12, this is an infinite series and the second one is a finite series. We have seen that for the above two series, we could get the next term from the previous term, except of course for the first term, because they do not have any previous term, by adding a common number which can be either positive or negative. Because for the first series, we add a +3 to each number to get the next number. 3 plus 3 will be giving us a 6, 6 plus 3 is 9, 9 plus 3 is 12, and so on it goes. But for the second series, the number that has to be added is a -1, that is -5. So 25 plus -5 gives us a 20. 20 plus -5 gives us 15. So the common number can be positive, either positive or negative. In the first case, we are having a positive common number, whereas for the second case, we have a negative common number which has to be added every time. Such progressions are known as arithmetic progressions, or abbreviated as AP. A dot B dot. A for arithmetic and P for progression. The series, first of all, they should be progressions. The series should be having some law which will be governing the numbers, the existence of the numbers in the series, present in the series. So those series are known as progressions that we have already learned, and the progressions for which the next number can be obtained from the previous ones by adding some common number are known as arithmetic progressions. For these two series, we are seeing that we can add a common number to every number and get the next number. And that common number can be either positive or negative. Now coming to the third series. For the infinite series 2, 4, 8, 16 and so on, we cannot find any common number which, when added to a number of the series, gives us the next term of the series. 2 plus 2 is 4. But if we add a 2 to this 4, we will be getting a 6, not 8. 4 plus 4 is 8. But if we add a 4 to 8, we will be getting a 12. If we add a 2 to 8, we will be getting a 10. We will not be getting 16. So we do have a common number, that is 2 in this case, but that has to be multiplied with the previous term to get the succeeding term. It cannot be added. It has to be multiplied. So this is not an arithmetic progression. This is not an example of arithmetic progression. For an arithmetic progression, there should be a common number which can be either positive or negative, which has to be added, which will be added to the previous term to get the next term. If there exists a common number which can be added to any term to get the next term of any series, that series will be known as an arithmetic progression, will be an example of arithmetic progression. The first term of any arithmetic progression is known as the first number, that is 3 or 25. The first numbers of any arithmetic progression is known as the first term. And the common number which has to be added to each term in order to get the next term of the progression is known as the common difference. As why the common difference? We are seeing the common number is being added. So the difference is not synonymous to addition. So common we do understand because it is the common number. Why is this term word difference? Because this is the difference between any two consecutive terms in an AP. Now, difference is always taken from the next term minus the previous term. So it will be 6 minus 3. 6 minus 3. We will be taking second term minus the first term. You see, every time there will be the same difference. 6 minus 3 is 3. If we do third term minus the second term, 9 minus 6 again equal to 3. 12 minus 9 again equal to 3. So this 3 is the common difference. So throughout an AP there will be this common difference, which is the difference between any two consecutive terms. For the second series, we'll be taking 20 minus 25. This is equal to minus 5. This is again equal to 15 minus 20. Equal to 10 minus 15. Okay, equal to 5 minus 10, and so on, 0 minus 5. Every time we see this, that the difference between any two consecutive terms is minus 5. So here comes the significance of this term difference, because we are subtracting. If we subtract any two consecutive terms in an AP, we will be getting this common difference. This is the same number which has to be added to the previous term to get the next term of an AP. So students, let us end over here. We have learned which series is known as an arithmetic progression. We have learned about the first term, and we have learned about the common difference. What is the common difference of an AP? Thank you for hearing.